Consider a 5% coupon treasury bond maturing on the 15th of May 2027. For settlement of 23rd of June 2021, the yield on this bond is 4%. We want to find the modified duration and Macaulay duration for this bond, and we want to estimate the change in present value on $800,000 of principal of the bond if the yield changes to 4.25%. Now, remember, the modified duration is the opposite of the relative rate of change of the present value. So that's negative PV prime, the derivative with respect to y, the yield, divided by the present value. When we're estimating our change in present value, we're going to need the present value, so we'll do that calculation as well. Then finally, Macaulay duration is the modified duration times 1 plus y over 2. So times effectively 1 period of interest. So let's go through, do our calculations. We've got coupon, it's 5%. The maturity is May 15th, 2027. The settlement date is June 23rd, 2021. The yield is 4%. The yield is going to change to 4.25%. And we won't have principal of $800,000. Okay. We're going to use Excel functionality to do these calculations. So the modified duration is calculated with M duration, settlement date, maturity date, coupon, yield, and then semi-annual because it's U.S. Treasury, actual over actual basis because it's U.S. Treasury. The modified duration is 5.0724. The Macaulay duration takes the same parameters, but we just call duration. Settlement, maturity, coupon, yield, 2, 1, frequency of 2, twice a year, semi-annual, basis of 1, it's U.S. Treasuries. The Macaulay duration is 5.1739. Remember, the Macaulay duration, one interpretation of that is when do you receive the average present value of the bond? So what's the average present value of the bond? When does it occur? 5.17 years. Okay, in order to estimate the change in present value, we need the present value. So I'm going to calculate that. In order to do that, I need my prices. So I need to calculate the clean price, the accrued interest, and the dirty price. The clean price, I can use the Excel function price. That takes the settlement date, the maturity date, the coupon rate, the yield, redemption 100. The clean price is for $100 of principal. The frequency 2, basis is 1. There's my clean price. Accrued interest, I'm going to calculate separately the previous coupon date and the next coupon date. Often I would wrap this all into one function call, but I'll do it here or into one cell. Previous coupon date is coup PCD for previous, settlement, maturity, semi-annual, 1 for U.S. Treasuries. Coup NCD is the next coupon date, settlement, maturity, 2, 1. So this bond matures on the 15th of May 2027, and so it has coupons in May and November. Given that settlement is in June, the previous coupon's the 15th of May, the next one's the 15th of November. Accrued interest I can calculate with the function ACCRInt. The first two parameters are kind of misnamed given what we want to do with this. The issue date is going to be the previous coupon date. The first interest is going to be the next coupon date. So previous, next, and then everything is pretty standard. Settlement, coupon rate, par is 100. It's going to go with our prices. Frequency is 2 for semi-annual. Basis is 1 for U.S. Treasuries. There's our accrued interest. The dirty price is the clean price plus the accrued interest. The present value of our bond position. Remember, the dirty price is for $100 of principal. We're interested in $800,000 of principal, so we take the dirty price, divide it by 100, multiply it by 800,000. This bond position that we're wondering about is worth $845,844.18. The estimated change in present value, we're using differentials here, is equal to negative modified duration times present value times the change in rates. So 4 1/4 minus 4. We expect to lose, rates are going up, bond prices go down. If rates go up by 25 basis points, 0.25%, we estimate that we will lose $10,726 using the modified duration, negative present value times the modified duration times change in yield. We can do the same with the Macaulay duration, equals negative present value times Macaulay duration, but we have to divide by the 1 plus the initial yield divided by 2 times change in yields. And of course we get the same answer because Macaulay duration is modified duration times 1 plus y over 2.